Well, hello, this is Mistaken for It again, and I hope that the previous video may have helped you see how we organize the Punnett squares for dihybrid crosses. But as I mentioned, they can be rather tedious, they can be quite laborious, and once you understand the probability, quite unneeded as well. So I'm going to show you some just basic probabilities for you to kind of conquer some of these things, kind of take the fear away from these dihybrid crosses. And one of the big assumptions we make, and it is an assumption, and um, we haven't talked about linked genes yet, but we are assuming for now that these two genes are on different chromosomes. And if they are on different chromosomes, they sort independently. Now, I mentioned this in the previous video. And the way you want to think about this is you could have that big R and little r. And then for the chromosome bearing the Y gene, you could have big Y, little y for the yellow and green allele. However, you could also, that's one arrangement, but the chromosomes could also line up like this. Now, the reason we say independent assortment is whether or not the big R lines up over here on the left does not affect whether or not the little y sorts there. In other words, the lining up of the yellow the lining up the round and wrinkled chromosomes have no bearing on the yellow and green. They're independent of one another. Now, we briefly talked about in class the fact that if you have two independent events, when you want to find out the probability for those two independent events occurring, you can multiply. You can use the rule of multiplication. So if I wanted to know the probability of flipping a coin and getting a head the first time, and then flipping a coin and getting a tail the second, it would be 1/2 times 1/2, and you'd have 1/4. So once we understand that first and foremost, these two sorting events are independent, then we can do something clever. We can say, well, look, all I need to understand is what's the probability of getting round, and then what's the probability of getting green. And once I know that, I can just multiply those two together. So here's a little trick. We've set it We've set it up as a dihybrid cross, but why do we need to work on it as such? So what the little trick is, pull these chromosomes out and make our monohybrid crosses. So big R cross big little. And then let's do the Y's. We can take them out and do big little cross big little. Now, these are way more familiar to us. This is just a good old basic monohybrid cross. But look at the power. Now, if I asked you for this, what's the probability of having a round P? Now, round is a dominant trait. So we're looking at good old big R, big R, little r. Well, this is going to be round, big R, big R. This is going to be round, big R, little. This is going to be round, big R, little. And then this is going to be wrinkled, little r, little r. So if I asked you, oh, what's the probability of having a round? Well, you'd say very correctly 3/4. You are certainly welcome to do the percentages. I think multiplying fractions is a little easier, but knock yourself out. And then if I said, well, what's the chance of having a green P? Now, green is recessive, so you need two little y's. But you can set up your Punnett square. I'm going to try and make my little y's very obvious there. This is big Y, big Y. This is big Y, little y, big Y, little y, and then little, little. Here's our green. So what's the probability of getting a green? 1/4. And lo and behold, if I multiply those, because remember they're independent events, that would be 3 out of 16. Now, you might recall from the other video that we found that there were some really fun ratios going on here, 9331. Well, I asked you for the chance of finding a round, green, and we just figured out mathematically it's 3 out of 16. Well, looky here. Round, green, 3, and that would be out of 16. Not convinced yet? Well, what's the chance of getting a round, yellow? Well, what's the chance of getting a round? 3/4. What's the chance of getting yellow? Big Y, that's yellow. Big Y, that's yellow. Big Y, that's yellow. 3/4. 3/4 times 3/4, 9 out of 16. Well, looky there. And let's keep going. What's the chance of getting a wrinkled yellow? Well, you should be able to figure this out and hit pause. And if you did so, you should know that, well, getting a round yellow would be 3/4. Getting a wrinkled um, sorry, it would be 1/4 because there we go, because the wrinkled is little r, little r. So here we are back to our 3 out of 16. So that was our other three right here. And then just the last one, just to really drive it home, what's the chance of getting a wrinkled green? Well, wrinkled is 1/4, green is 1/4, and suddenly we're at 1 out of 16. Well, there you go. So it's a really, really clever way to figure these out. Now, let's do another one. Let's use the same symbols just so we're not throwing too many new things in the mix. What say we take our heterozygous, big Y, big R, little r. Um, I think just for the sake of consistency, I did big R, big Y, little y. Let's keep that. What if we then did a homozygous recessive? And a homozygous recessive, little r, little r, little y, little y. Now, this one you could do a Punnett square pretty reasonably fast because, well, this is only going to be little r, little y. So even if you did a 16 square Punnett, you would real quickly realize that all of these rows would have the same gamete. And so they're going to be just copies of what you do above. But what is this heterozygous going to be? Well, the 16 square would be, let's do our FOIL, the big R with the big Y, big R, little y, little r big, little r little. So we would set it up like so. And then you could figure it out that way. So you could. And in fact, I want you to. I want to see the next time we meet, I want to see you figuring out the top row. And honestly, that's all you need to do. If you don't believe me, you can do all 16. Be my guest. But what if we wanted to do it by the probability rules? Not not bad at all. So let's go ahead. Let's pull out our monohybrid, big R, little r, cross, little r, little r. And then let's pull out our y's, big, little, cross, little, little. Now, at this point, it becomes our nice, easy monohybrids. So you can do this. Please go ahead and fill out your Punnett squares. Now, remember I told you the more you can memorize or know very, very well these basic monohybrid ones, the better you're going to be because these all follow the same pattern. And I just goofed. I'm so sorry. These follow the same pattern. So if you have a big little cross little little, you're gonna get 50% big R, little, big, little, and then 50% little, 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 little. So let's go ahead and do this. What's the chance of getting round? The chance of getting around is 1/2. What's the chance of getting wrinkled? 1/2. Technically 2/4. I think you can handle reducing that. Over here, what's the chance of getting yellow? Well, this would be big, wide, little, big, wide, little. This is yellow. Little, 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 little. Here's our green. So again, what's the chance of getting yellow? 1/2. What's the chance of getting green? 1/2. So let me leave you with this because I think at this point you can do this. Go ahead and now that we have our monohybrid probabilities, use your rules of multiplication to figure out what's the chance of having a round round yellow. I keep making that mistake. I do apologize. What's the chance of having a round yellow offspring? What's the chance of having a round green? What's the chance of having a wrinkled yellow? And what's the chance of having a wrinkled green pea plant? And you should be able to use those probabilities to determine your final probabilities. It's not bad. In fact, I think it's quite a elegant way to solve these without having to resort to drawing those squares. Um, it's nice to understand why the squares work. But it's even nicer when you understand how to use math to figure this out. So go ahead and try your hand at this. If you want, there's one last challenge, and it goes back to what we left off in class today. Here's our blood type and our sickle cell. So let me leave you with one challenge. What would be the probability of if we had a man and a woman who have a child, and this would be the dad, this would be the mom. What would be the chance of having a child that is type O and completely normal, no sickle at all, completely normal hemoglobin? All right, I'll throw that out to you and see if you're up for that challenge. And I hope this helps. We're going to hopefully hit the ground running when I see you next. Thank you.